What is up, winning team? Hello and welcome back to chapter 10 part B. Today we are continuing our current book series on the channel, reading Beyond the Veil, exploring the bubble theory and the fourth dimension, a beginner's journey into the higher dimensions and modern physics. And I decided to split chapter 10 into two parts because we kind of discussed in 10 part A about this concept that what if gravity is a manifestation of interdimensional interactions? What if what we understand about gravity so far is actually wrong? And also the things within science that give rise to the idea that that what we think about gravity could be wrong, the actual tangible observable evidences. Go and check out that previous video if you haven't, to catch yourself up. If this is the first of all the videos you're watching of the series, please don't forget, if you want to catch up, check out the playlist in the description box. Has all the videos in order. You can watch them all the way through from the intro, which explains why we're doing this, all the way through till now and beyond. Also, you can purchase the book for yourself on Amazon. It is super cheap. Please go and look at that as well if you'd like to get it for yourself. I know this is a book I wish they had stuff like this when I was at school, like instead of just giving me like books about, I don't know, whatever else nonsense fiction malarkey. And finally, if you are a scientist who is aware of these types of concepts, you're into quantum science, maybe you're a physicist, whatever, there is also more details as given by the author. He sent me a link that in the description where you can go and look online at further, more detailed information to explain these ideas. We're now going to be moving on to the mathematical framework simplified. So where this whole concept of this gravitational thing coming maybe not so much in the way we understood it from our dimension, but in a fourth dimensional sense, and the challenges in future work. Like I said, if you want to get up to date, go and check out the previous video. Let's continue. So the mathematical framework simplified. Higher dimensional field equations. At the heart of the bubble theory lies a set of extended field equations that incorporate the fourth spatial dimension. These equations describe how the S energy field interacts across multiple bubbles. I have to see these. Influencing the fundamental forces. While the complete mathematical formulation is intricate, the simplified versions captures the essence of the higher dimensional interactions. Energy conservation across dimensions. Energy conservation remains a fundamental principle within the bubble theory. However, in the context of higher dimensional interactions, energy exchanges between bubbles adhere to adapted conservation. Let me read that again so it's not confusing. Energy exchanges between bubbles adhere to adapted conservation laws that account for the fourth dimension. This ensures consistency with established physical laws while allowing for the emergence of new phenomena. I like this. Quantum mechanics integration. Integrating quantum mechanics with the bubble theory involves reconciling the probabilistic nature of particle interactions with a deterministic framework of higher dimensional dynamics. This is achieved through advanced mathematical techniques that bridge the gap between quantum states and bubble interactions, fostering a unified description of reality. In layman's terms, for those of you who might be feeling a bit confused, essentially, as I was saying previously, there are some things amongst science, i.e. the probabilistic nature of particle interactions versus the deterministic framework of higher dimensional dynamics. These are all based off of the believed laws that exist. So kind of like how the issues surrounding the general relativity and how we end up with Einstein's theory of general relativity, with all of that, between the issues that were coming between what Newton was stating about and what Newton was stating in terms of law of motion, and then also with Maxwell and what he was stating about electromagnetism, and how although both things individually could be proven, there had to be adjustments made and a more understanding delved into for those two things to be able to make sense simultaneously. It's kind of similar to what's happening here. And again, I'm massively oversimplifying this, that we're suggesting that the bubble theory, this whole concept of the fourth dimension and this whole concept that this fourth dimensional interactions between bubbles might be a greater and more accurate explanation for even the observable things we see about gravity, is able to actually connect the probabilistic nature of particle interactions as well as the framework of higher dimensional techniques. So that makes a lot of sense. Challenges and future research. So this is where it gets interesting. Empirical validation. One of the primary challenges for the bubble theory is empirical validation. Detecting indirect evidence of high-dimensional interactions requires sophisticated observational techniques and precise data analysis. Future research must focus on refining these methods to identify the subtle signatures predicted by the theory. That's insane. As an insane task to try and take on. Theoretical refinement. The mathematical methods underpinning the bubble theory need further development to provide detailed. Oh my gosh. Okay, let's just start this again. Sorry, my brain is racing at 100 miles because I'm really thinking about a lot of stuff. So when I'm trying to read, my brain is going at 1,000,000 miles into whatever I'm thinking already based on what I've been reading. But let's continue. The mathematical models underpinning the bubble theory need further development to provide detailed predictions and align with existing physical laws. Integrating quantum mechanics with high-dimensional field theories remains a significant hurdle that requires collaborative efforts across multiple disciplines. So that's something I've actually spoken about to you guys before a lot, and why another one of the very many reasons I don't necessarily believe science is this ironclad, trustworthy thing, because science is always going to have some level of bias in the sense that any type of research that is done is going to take somebody who chose to do it, people that chose to fund into it for it to become something that's considered acknowledged or peer-reviewed or official by the public. So when people say scientific research has proven ... in society, that means that somebody came up with the hypothesis, the theory, the whatever, right? Other people jumped on board to support it. Somebody probably funded it and it had to happen. So that also means that just because something isn't proven doesn't mean that it's not true. And that's one thing that I like to throw back at people as a person who believes in the supernatural and in science. It goes back to the Schrodinger's cat thing, right? You don't know if the cat is dead or alive. So I'm like, you can't prove to me. Sometimes if something also can't be proven that it's not true, don't be so quick to be against the fact that it could be true. So like in this sense, yes, we may not be able to fully prove all parts of the bubble theory. And I'm not saying that you should believe the bubble theory. I'm just I'm just like stating my case in terms of being open-minded. But the same way that you might feel that it's not proven that the bubble theory is true. Unless you can prove that the bubble theory isn't true, then you should be open to either option, and we should all be open to either option if we're going to be honest, critical thinkers, is all I'm going to say with that. So technological advancements in telescope technology. I'm so mad we stopped doing telescopes. You guys don't know how badly I want to buy a telescope, and I will absolutely be buying telescopes for my children, by the way, for them to study. It's sad that we don't do that anymore. Advancements in telescope technology, particle detectors, and computational modeling. So I did computational. That's what I was doing for my own quantum research. I was doing computational predictions of molecules in outer space. And computational modeling are essential for testing the bubble theory's predictions. Investing in next generation instruments will enhance our ability to observe gravitational wave anomalies, black hole behaviors, and cosmic structures with greater precision. So again, just to highlight that, for that research to happen, somebody has to take that on, somebody with enough power, influence, money, whatever. Henceforth, again, why just because that isn't there, the proof isn't there yet, doesn't mean that it's not true. Not to say that I'm saying it is true. I'm just saying that at this point, both options are open and both options should be addressed equally. That's what I'm saying. Interdisciplinary collaboration. Address the complexities of the bubble theory addressing the complexities of the bubble theory necessitates collaboration between physicists, mathematicians, computer scientists, and astronomers. Interdisciplinary research. So rude that you didn't include chemists in here, by the way. I just want to say. Rude. Considering you're talking about atoms and you're talking about like the fundamental forces. So rude to have left chemistry out of this. Just want to say, if you're watching, Jamil, so rude to leave chemistry out of this. Like as if we're not a big part of this. But anyway, because we're talking about atoms, we're talking about, yeah. Anyway, interdisciplinary research initiatives can foster innovative approaches to solving the theory's challenges and accelerate progress towards validation. Of course, as is usually the case with a lot of science, it's hard to ever really, as I was just trying to say, I was throwing shade at the author, but it's hard to ever really look at anything scientifically in one individual scientific disciplinary, because they also have their overlaps in a lot of ways, and different ways they each explain each other. So you kind of have to look at it from all angles, which is, again, another proof of what I was saying about why research is hard, because you would have to have essentially experts in each of those individual fields to come together to look at this to help to get to the crux of it all. I'll give you guys an example. I always use this example because it's a simple one to understand for the average person, of Gregor Mendel, my favorite scientist, who was the one who discovered genes. Now we have dominant and recessive alleles in our genetics, and that genetics, you're not just 50-50 your parents. Technically speaking, he was a mathematician, and technically speaking, when he wrote his notes on him crossbreeding all of these plants, he was crossbreeding the peas in particular, people didn't understand, the biologists didn't get what he was talking about, right? Because it was written in mathematical language. It was only after he passed away that people saw what he wrote, and then they realized that he'd made a huge scientific discovery and breakthrough for our understanding of DNA, how children develop genes and genetics, and so on and so forth. Goes back to what he's saying here about the interdisciplinary needs. Like, there has to be people with more of this side of understanding this than that. For me, and with this, I can tell you that as soon as we start talking about anything relating to chemistry, it makes a lot of sense to me, more so than perhaps some of the physics elements, and hence why we have to all work together. You know what I'm saying? So I'm trying to say, we all work together, and yeah. So anyways, the conclusion, the bubble theory offers a transformative perspective on gravity and the fundamental forces, proposing that what we perceive as gravity emerges from higher dimensional interactions governed by the S energy field. By unifying gravity with electromagnetism, the weak force, and the strong force within a cohesive framework, the theory bridges the gap between quantum mechanics and general theory. Bear with. While significant challenges remain in empirical validation and theoretical refinement, the bubble theory stands as a promising avenue for advancing our understanding of the cosmos. Continued research, technological innovation, and interdisciplinary collaboration, which includes chemistry, will be pivotal in uncovering the truths that lie beyond the visible veil. Key takeaways from Chapter 10, gravity as an emergent phenomenon. The bubble theory suggests that gravity arises from interactions between bubbles in the fourth spatial dimension rather than being a fundamental force. Right, so that's really interesting. And if you want to understand that, you obviously need to have been keeping up with the previous videos. And like I said, if I were you guys, I would get the book, because I even have to keep going back and reading back and going forth and then recapping other topics off, like completely out of the book, and to keep up with this, because this is a new concept. So your brain is going to struggle to completely comprehend all of this, and you're going to have to really delve deep. And like I said, link to the book in the description, link to further, more detailed information also in the description box, and link to the full playlist in the description box. So we'll continue with the key takeaways, which is basically at the end of each chapter, he kind of summarizes everything that he said. Unifying fundamental forces, the S energy field serves as a common thread linking gravity with electromagnetism, the weak force, the strong force, and offering a potential unified framework. So we want a unified framework for the fundamental forces, bridging quantum mechanics and general relativity by positing that both quantum phenomena and gravitational forces emerge from high dimensional interactions. The bubble theory provides a pathway toward unifying these two pillars of modern physics. Potential evidence, gravitational wave patterns. Unique signatures in gravitational waves could indicate higher dimensional influences. Black hole behavior. Deviations in black hole mergers may reveal interdimensional interactions. Cosmic scale structures. Anomalies in the distribution and movement of cosmic structures might hint at the collective behavior of multiple bubbles, which is really interesting. Mathematical framework. Higher dimensional field equations and adapted energy conservation principles form the mathematical backbone of the theory, facilitating the integration of quantum mechanics with gravitational dynamics. It is what it says on the tin. Challenges and future work, of which there are 1, 2, 3, 4. So we've got empirical validation, theoretical refinement, technological advancements, and interdisciplinary collaboration. So in terms of the empirical validation, we have to developing sophisticated observational techniques to detect subtle signatures of high dimensional interactions. That's the empirical validation element. Theoretical refinement, enhancing mathematical models to align with existing physical laws and provide detailed predictions. Technological advancements, investing in next generation instruments, which somebody has to choose to do and choose to pay for, and be able to afford to observe gravitational wave anomalies, black hole behaviors, and cosmic structures with great precision. And finally, interdisciplinary collaboration, fostering cooperation between various scientific disciplines to address the multifaceted challenges of the bubble theory. So essentially what we're saying that is that the further we go, there are a multitude of different things that are leading to why these are still very much theories and not like accepted science, like many other things that we believe in, like the laws of thermodynamics, the laws of motion, etc., because we're still yet to be able to prove the empirical validation, as he said, the need for, and again, a lot of this, and I'm saying this just as kind of a side note for people to be aware of, that while you're busy trusting in all of science, you got to remember that whatever scientific stuff that we know, it's a result of a combination of somebody knew, somebody had an idea, that person or those people were able to get funding to pay for things like the equipment. Like when I was doing my own scientific research, we had a specific budget for like my research project. And even for part of my future work of my research was, had I had a bigger budget, I could have done way better calculations because mine was computational chemistry based. I could have done a lot more calculations. I could have done a lot more specific calculations and explored much deeper theories. But the limitations of my own research were simply that I didn't have the funding. So that's on a very small scale, right, for what I was doing. On a larger scale, with these bigger ideas, with these bigger potentially scientific breakthrough level of hypotheses, you have to be able to have the funding, the personnel, as we mentioned, the interdisciplinary collaboration, the various people, because again, as a scientist, most scientists, the further you go down the line, and I don't know if people realize this, but the further you go down the line, the more you tend to specialize. So like as a scientist, the further, as a chemist, the further I go down, I go from initially I'm doing inorganic, organic, physical, etc., all these different kinds of chemistry. But if I'm now going to go and do a PhD, I'm probably going to pick one of those areas. Like, and then once I go further down that area, I'm going to pick an even more specific area. So you need people who are like expert in all their different individual fields to kind of come together a lot of the time, because there's not enough time in the world for all of us to fully study all the areas of science, and hence why ultimately God will always reign supreme above science for me, because he's the only person and the only even concept that could actually contain in real life terms the fullness of the understanding of everything. Anyways, guys, that was chapter 10. Let me know your thoughts in the comment section down below. Let me know if you're enjoying this. Like I said, everything is linked in the description box, the playlist, the book to buy on Amazon, the further information, more detailed if you're interested, is all linked in the description box. Buckle up and stay tuned. This is getting so juicy. This is getting so good. I can't believe how close we're getting to finishing the book even, and we're just going to have to keep going, because now we've started. Now that the train has left the station, we ain't stopping. So this is just the beginning of our delving into the fourth dimension. I told you guys we would be here. For those of you who've been here for a long time, you already knew that this was coming, and we're finally here. And special shout out to Jamil Chamberlain, the author of the book, who I do happen to know, as I've mentioned in a couple of videos, because he is indeed the husband of one of my friends, and who has actually been so supportive of this whole series and has been answering my questions and giving me all sorts of insights about all of this. It's just great. And even going back to his interdisciplinary collaboration it was talking about, I, as a chemist, it's so interesting to hear from somebody who is in the physics element of this all explain some of these concepts, which are very much above my personal pay grade as far as like understanding some of this stuff. So it's new to me, a lot of this, and it's challenging me scientifically, which I'm enjoying so much. Anyways, you guys, if life's a game, it's paid to win. God bless you all. God loves you. I love you. And I'll see you in my next one.